Hi everyone, my name is Benjamin, and in this video I will show you how you can set up your local Solana development environment, and in particular the Solana CLI, to get you started building on Solana. We are going to talk about how to install your development environment including Rust, Anchor and the Solana CLI, what the different Solana clusters are, how to properly configure the Solana CLI, and how to run your own local built-in test validator. And finally, we are going to create and deploy our own Solana program. And if you have questions or want more information, consider joining our great Discord community. Link will be in the description, and we hope to see you there. And with that said, let's get started. Alright, so in order to proceed with the installation, a great place to start is always the Solana documentation, and you can find it by going to solana.com/docs. And here you will see under getting started, there is a installation section. And if you look at that, you will see what prerequisites you will have to install before you can continue with the installation itself. Now, if you are on Linux, it's quite straightforward. If you are running, for example, a Debian-derived operating system, like for example Ubuntu, the only thing that you will have to do is run this command to install some dependencies. Now, if you are on Windows, it's a little bit more complicated, but it's not that hard. The only thing that we will have to do is install the Windows subsystem for Linux. And what that means is that we are going to install Ubuntu on top of our Windows installation. And we are going to use the native virtualization platform that comes with our Windows installation called Hyper-V. We do that by installing the Windows subsystem for Linux. And you can do that really easy by running this command here, wsl-install. So you copy this command and you run it into a PowerShell window or a terminal window, and then once you run it, it will install WSL for you. Now, if you want to check if you already have it installed, what you can do is type WSL-V, and then it will output that version here for you. Once you have it installed, what you can do is open Ubuntu by going to the start menu, and that will open Ubuntu for you, and then you can continue with the installation. Or you can also open the terminal such as we did here, and you can type WSL. Also, this will start the Windows subsystem for Linux for you, and it will direct you into that Ubuntu instance. These are two ways of doing that, and if you scroll down a bit, you will see that you can also access it via Visual Code, and that is how we are going to work. I opened a Visual Code instance here, and as you can see, I just created a project or a empty folder called Solana CLI, and I opened a terminal here, and I do that by going to Terminal, New Terminal. Now, the next thing that we can do is click on this small arrow here and choose the Ubuntu WSL, and also here you will see that we are into that Ubuntu instance that we created. And great thing is that we can see all these files here now here on the left, and also here within our Ubuntu instance, because it is mounted within that instance. So if I, for example, create a file here, like let's say echo test, and then we output that in a file called test.txt, then you will see that it also appears here on the side, and you can see it says here text. And if I say like, hey, greetings from SVS, and I save that file, I can also cat that file here, as you can see, and it will say, hey, greetings from SVS. And we can also remove that file here, and if we do that and then we check if there are any files here, you will see that there are none. So it's a really great way to actually interact with both the Ubuntu instance that we created. We have our PowerShell instance here as well, and we have all our files here within our project. And later, if we create a Solana program, we can have a nice overview of our files here, and we can interact with the Solana CLI via the Ubuntu instance that we created. Now, the next thing that you need to do once you have these prerequisites installed is, of course, install the Solana tools themselves. And you can do that by just running these commands here. So you can go to the documentation and just click copy. And if we go back to our instance here, if we clear our terminal and we just paste this command, what it will do is start installing all these tools for us. And we just have to enter the password that we set up in the first place, and then you'll see that it goes and downloads all these packages, all these libraries, all these tools, and installs it within our Ubuntu instance. And here you can see installed versions, and it says Rust, Solana CLI, Anchor, Node, and Yarn. And that is what is expected, because if we look at the documentation here, it says a successful installation will return these outputs. And also you can double check it by running this command here. So if we copy that as well and we paste it here, what you will see is that we have all the versions here. And of course, you can also do it one by one. If we would type node -v, you see that it exactly has the same version as it says here. So that is how we install all these tools and features that we can use to develop in Solana. Now, before we continue, I just want to mention a other way of installing this, and that is called Mucho. So if you go to github.com/Solana Foundation/Mucho, and here it says that Mucho is a command line tool designed to simplify the development and testing of Solana blockchain programs. So that sounds really interesting, but we can also use that to install all these tools that we just installed by using the official documentation. And what you have to do is just copy this comment here, so we can do that. And it says here, if you want to install Mucho and all the core Solana development tooling at once, you can just copy this comment here. And if we do that and we go back to our instance, what we can do is just paste this comment here, and you will see that this also will install all these tools that we just installed, because here you can see Mucho is already installed, Rust already installed, Solana already installed, Anchor already installed, and also Yarn. And 2 tools were updated, and that is because I already installed via Mucho itself. But as you can see, this is also a way of installing all these tools to set up our development environment. Of course, Mucho comes with a lot of additional features, and if you want to check them out, you can do that. I will put the link in the description that you can check it out yourself, and also use it to install via a alternative way instead of the installation documentation from Solana. Alright, so before we dive into the Solana CLI, let's have a brief talk about Solana clusters. Now, you can look at clusters as a group of validators where each group serves its purpose within the overall Solana ecosystem. Now, within these groups, we have dedicated nodes that respond to RPC requests within this cluster. Now, there are 4 major clusters. You have mainnet beta, which is the live production, where we all like to transact and deploy applications. And then you have devnet, testnet, and of course localhost, and we are going to localhost later on. Now, these nodes within these clusters are owned and operated by third parties. However, there are also public endpoints available for all these different clusters, for devnet, for testnet, and for mainnet, of course, and these are owned and operated by the Solana labs. Alright, so just to recap, a cluster is a group of nodes, and each node is an individual machine within that cluster that handles requests. Now, for example, a node in the devnet cluster processes RPC requests on devnet. To interact with these nodes, you can use endpoints that these nodes expose. And some of these endpoints are public, like the ones from the Solana Labs and the public one from Solana Vibe Station, while others are private and require payment through an RPC provider such as Solana Vibe Station or Helios, for example. Alright, so let's have a quick look at the official documentation about clusters and RPC endpoints. And here you can see that they list them both for mainnet, devnet, and testnet. And these are these public endpoints available for you. They have a quick purpose overview, nodes overview, and also a bit more details about devnet, about testnet, and also the mainnet beta. Now, the main takeaway is that these are public RPC endpoints, and as it says here, they are not intended for production applications. So the moment you are going to build an application or you need some production ready RPC endpoints, you should consider purchasing your own RPC endpoints, and of course you can get these through SVS. Now, besides that, mainnet is of course using real Sol, whereas devnet and testnet is using fake Sol. That's also a big difference. Now, if you want to read more about the differences between the different clusters, you can do that. Also important is that there are many explorers that we can use to check out these different clusters, and we will have a look at solscan.io later, where we can check out what we're doing. We can look at certain transactions, and also here we can choose to look at the different clusters, for example mainnet, testnet, and devnet, and also our custom one, which we will do later on once we set up our own test validator, and then we will check out some transactions that we do on that test validator, and we can have a look at that via the solscan.io by providing our own custom RPC. So that's what we are going to do next, and with that said, let's check out the actual Solana CLI. Alright, so back to Visual Code, and again we are running this within Ubuntu and we are using the Windows subsystem for Linux, but this should work for you if you're using Linux or macOS as long as you have the Solana CLI installed. If we type Solana, you will see that it returns all the subcommands that are available to us, and we will have a look at some of these, which you will use a lot if you're doing Solana development. However, if you provide a subcommand, you will also see that it provides us information back about that subcommand. So if we type, for example, Solana Solana config, we will get all the information regarding this subcommand and also what additional arguments we need to provide before it can do something against the ledger or on our local computer. So you can type these comments, and again, if it needs more information, it will prompt you. And if you want more information, you can also just type the subcomments and then it will give you back additional information and a list of subcomments that you can use to interact with the Solana blockchain. All right, so let's clear our terminal real quick and then we can have a look at Solana config get. And this will show us the current config that we are using with the Solana CLI. You can see that we have a config file, and this file holds all the values that we can see here. So if I cat this file, what you will see is that these values represent the one here on top. We have a RPC URL, a WebSocket URL, and a key pair path, and of course a commitment. Now the RPC URL is pointing to mainnet at the moment, so everything that we do on the Solana CLI will be against the mainnet cluster. And we also have a key pair path, and this key pair path points to a file which holds a private key where we can derive a key pair from. So if we cat this file real quick, so what we can do here is cat like that, you will see that we have our private key here. And based on that private key, we can create a key pair. And then with that key pair, we can do all kind of stuff. For example, we can sign transactions, we can deploy programs, all based on that key pair, because we can create or derive a key pair better from this private key. Now, you should never share this private key because everyone that has it can recreate that key pair for you and sign these transactions in your name. Now, don't worry, I will remove this wallet later so you don't have to try to recreate it. And we're also going to create a new wallet together. Alright, so let's get rid of that key pair that we just exposed, and that we can do by creating a new one. So we can use the command solana-keygen like this, and probably we have to provide additional arguments, but let's just check what we need to do. And here it says if we want to generate a new key pair, we will have to specify the new argument. So we can type solana-keygen new. And as we already have a wallet, it will refuse to override that private key that we just viewed. But we can still do that by providing it the force flag. So we will do that, and then we will have to provide a passphrase, just something simple for now. We confirm it, and then you will see that we have a new wallet available for us. And what it will do is output the public key and the seed phrases that we can use to recreate this wallet as well. Again, this is also a method of recreating that key pair. So also these phrases you should never share. Just as you will never share the private key, these phrases you can also use to create that wallet or that key pair. So don't share them again. As you can see here, now we have a public key for this Solana key pair or for this private key that we just created. And we can also check that out by typing Solana, I believe, address, just like this. And you will see that it also outputs the address that we just created here. It started with 4D and also 4D and GQ, and also here GQ. And we can also check the balance. So if you do Solana balance, you will see that we have 0 SOL within this wallet. And again, we are doing everything against mainnet, because if we type Solana config get, you will see that we are on the mainnet cluster. So let's change that real quick. So what we are going to do is type Solana config set, and then we are going to specify the URL. And we want to go to not mainnet, but devnet. And if we do that, you will see that we now are on devnet. You can also do this in a shorter way by typing Solana config set, and then just dash U for URL and then M for mainnet, then we are back at mainnet, or E for devnet, or L for localhost. As you can see, this is a really easy way to change between all these clusters. Alright, so eventually we are going to use the localhost cluster to deploy a program and then also check it out. Now, before we do that, we will need to have some Solana in our wallet. Now, we will request Solana to be airdropped in our wallet on our local cluster, but I just want to show you that this is also possible on devnet and on testnet. Of course, this is not possible on mainnet because it is real Solana, but if we go to the Solana config set and then we go to the devnet for a minute, what we can do is request some Solana to be airdropped in our wallet. And you can do that by typing Solana airdrop and then the amount of Solana. Now, there are some limitations, and it is possible that it will not do that because we can only request a certain amount of Solana each day. And as you can see here, it failed because we might have reached the rate limit. So what we will do is change to our localhost cluster and then request an airdrop for Solana because we don't have any limitations there. And to do that, what we can do is type again Solana config set, dash U, then L, and now we are on our local cluster. Now if we type Solana balance, you will see that this does not resolve because our local validator is of course not running. What you can do is, for example, type Solana address, and this will perfectly resolve because this is something that the Solana CLI does for us. It can recreate that public key, remember, from the key pair that lives within our file system. The next thing that we will do is start our local validator, request some Solana to be airdropped into our wallet, create a simple Solana program using Anchor, then we're going to build it, deploy it on our own local cluster, and also check it out. Alright, so what we can do now is go to Solana, config git. Then you can see that that config file lives here in the Solana CLI folder. So if we have a look at that folder, you will also see that we have a test ledger folder there. And here what we can do is type Solana test validator. And this will start a validator for us locally. Now, if you give it a minute, you will see that it starts processing slots. And again, if you start it, it will continue where it left off. So if I stop this and I start this once again, you will see that we are at slot 669. And if it starts up once again, you will see that it goes on from slot 669. So here you can see 669, or we are at 675 at the moment, but we can just start it and stop it. Now the thing that you need to remember is if you want to interact with this local cluster, you need to make sure that it runs and that you don't close the terminal. So what we will have to do is open a new terminal and make sure that we are going to the Ubuntu WSL once again. And then we have again here our Solana CLI, as you can see, Solana. We can use these comments. And we have our local validator running in the background. Remember that we could not get the actual balance from our wallet because the Solana validator was not running. If we do that now by typing Solana balance, you will see that it resolves this 0 here. I can show you if you type Solana config get, we are currently on localhost. So we know that our local validator is running properly. Also, if we look at the local validator, the local JSON RPC URL can be found at this address. So what we can do is go back to Solscan once again, and then under the different clusters, we can add a custom RPC. And if you then select the custom RPC connection, you will see that we are now connected to our own local cluster, you could say. Again, this means that we are up and running because if we refresh this, you will see that the current slot height is 943. And if we have a look back at our current validator, we are at 998. So this is correct. So we now have our local validator running and we can start with doing some actual stuff. So if we type again Solana address, this is our address, and also this address we can look up on our local cluster. So if we type it in here, you will see that this address is valid. It has no sol in it. And again, these wallets we can reuse within all the different networks or within the different clusters, because these wallets, they can be recreated from that private key both in DevNet, testnet, mainnet, and also localnet. Now, of course, if you have a sol balance in DevNet, that same sol balance is not being represented in a other cluster. So the sol balances are, of course, depending on the cluster that you are in. So back to our VS Code, what we can do now is do a airdrop by typing Solana airdrop. And here you can see that I can type 2 and it will drop that Solana into my wallet. I can also type 1000 and you see there are no limitations because we are on our local cluster. And as you can see here, we got a transaction back. And if we have a look at that transaction in Solscan, you can see what actually happened. So back to our wallet, now you can see that we have a balance of 10,002 Solana. And if we look at that transaction that we just copied, we can also see what happened there. And you can see that we interacted with the transfer program and we sent 10,000 Solana to that wallet. So if we go back and we copy our wallet here once again, and you look at that wallet, you can see that we have the destination, which is our wallet. So our local cluster is working. We can airdrop Solana, we can check out transactions. And the next thing that we can do is actually create a program using Anchor and then try to deploy it within our local cluster and also see if we can interact with it or get some output from it. Now, Solana programs, they are the foundation of building on the Solana blockchain. And you can compare it to smart contracts, which is code that is built and deployed on chain. Now this code, it can be called upon by clients or other programs and applications. Now, because we deploy this code on chain, by nature it means that it is immutable. So in other words, we cannot change it unless there is a upgrade authority retained, of course. Now this code doesn't hold any data and they're not connected to any database. They just handle the accounts that are being passed through them via instructions. Now within this video, we are not going to cover Solana programs in depth. We are just going to set up a simple Solana program using Anchor, which will create a scaffold or a boilerplate code for us, which we will slightly modify. We are going to build it, deploy it, and then check it out within our local cluster to see if it actually worked. Alright, so back into VS Code, we are now in the folder solana-cli, the one that we have here on the side that we can see all the files. And the next thing that we can do is type anchor init and give it a name like hello svs. And this will set up for us a boilerplate code like a scaffold of a Solana program that we can use to then deploy, build, and also test. Now, once that is done, you will see that it says hello svs initialized. And what we can do then is navigate to that folder like cd hello svs, and we can clear our terminal, and now we are within this project here that you see on the left. Now if you open the programs folder and then look at source, you will see a file called librs, and this is just a boilerplate code that we can play with. We have the declare ID, which is actually the unique ID of our program. We have a instruction which just outputs the message greetings from, and then the program ID, and we have some structs here on the bottom. What we can do is change this to, for example, greetings from Solana Vibe Station, and this is our first program ID. So now we changed that message slightly, so later on when we check the program logs, we can actually see that it is our small program. The next thing that we can do is type anchor build like this. And this might take some time because building these programs is a lengthy process, but once that's done, we will check it out and run a simple test against it. Alright, so eventually it was ready, and before we start the test, I want to make sure that our Solana test validator is running. We can do that by typing Solana test validator, and once this is up and running, we can go back and start the actual test. And we can do that by typing anchor test like this. And normally this should fail. As you can see here, because port 889 is already in use, and that is because our local validator is running on that port. And that is because this test under the hood, it wants to set up its own emulator, its own validator to do these tests. And that is of course not what we want. So what we can do is go to this file here called anchor.toml, and instead of using the cluster localnet, we can set that to our actual local validator. And that address, remember, we can find here. So if we copy this and we paste that here and then save it, if we now go back and rerun this test, now that test should be run on our local cluster and not on the one that it tries to spin up. And as you can see, now we got the signature back from the test, and it says here that it passed. So in theory, we can check out this signature now because it ran on our local validator that was running here in the background. So if we copy this signature and go back to Solscan and have a look at this signature, what we can see that this is our test that we just finalized. And if we scroll down, we can also see the program logs here outputting greetings from Solana Vibe Station, and this is the program ID that we declared. So we know that this is working, the test was successful, and it was run on our local validator. So one last thing that we can do is also deploy that, and that we can do by anchor deploy, just like this. And this in turn will deploy this application also within our cluster. And also here we get a signature and the deployment was successful. So we can have a look at that as well. If you go back to Solscan and then paste that signature in there. And of course, sometimes we have to refresh because it can take a bit. And now we can see that 18 seconds ago, this was deployed and the fee that we paid. And remember, if we go back and we type Solana address, just like this, we get the address and then we can have a look. And we are the actual signer and the authority of that program. So also the deployment was successful. We did it within our cluster, such as the test that we also ran in our cluster. And that is how you can simply set up a Solana dev environment using the Windows subsystem for Linux. And then we have access to that Ubuntu machine where we can interact with the Solana CLI. We can set up simple or more advanced Solana programs, and we can set up our own local validator, our own local cluster, and then work against that cluster. We can create programs, we can deploy them, we can test them against that cluster without having to do that against the actual Solana DevNet and Solana testnet or Solana mainnet, because that even cost us fees to deploy, for example. So it's always good to do this fully locally. And in today's video, we checked out how you can do that, how you can set it up. I hope it was interesting. If you think so, make sure to like the video and subscribe to the channel. A lot more content is on its way. We are also going to go more in depth into Solana programs and how to create them. And with that said, that's it for today. And I hope to see you in the next one.